Welcome to The Explainer. I am so incredibly thrilled to have you here today because we are going to unpack one of the most mind-bending, alluring mysteries of modern astrophysics. You know, if you've ever felt like you're just drifting through life, well, technically, you are hurtling through space. And today, we're going to talk about exactly what is pulling us. Okay, let's dive right in.
Consider this for a second. Our entire galaxy is being pulled towards something enormous. We can't see it, we don't know exactly what it is, yet we're rushing toward it at over 2 million kilometers per hour. I mean, this is literally the ultimate cosmic detective story. We aren't just sitting still out there in the universe, we are on a high-speed trajectory toward an incredibly massive, totally invisible gravitational anomaly. And I really want to just slow down and let this number sink in. 2.16 million kilometers per hour. That's roughly 600 kilometers every single second. Sure, the Earth orbits the Sun, and the Sun orbits the center of the Milky Way, but our entire Milky Way galaxy itself is just racing through intergalactic space at this unfathomable velocity. We are caught in a massive cosmic current, rushing toward a completely unknown destination.
So, how did we even figure this out? That brings us to Section 1, the Great Cosmic Mystery, the Dipole Anisotropy.
Back in the late 1960s, mapping the leftover radiation from the Big Bang revealed that one side of our sky was actually slightly warmer than the other. And that was our very first clue that we are moving at staggering speeds. To understand why, we have to look at what physicists call peculiar velocity. Right, so according to Hubble's law, the entire universe is expanding uniformly, which means galaxies should just be moving away from one another. But gravity kind of throws a wrench into that. Galaxies pull on each other. So a galaxy's true motion is a combination of the universe expanding and its own localized gravitational drift. That drift is its peculiar velocity. The fact that we have such a massive peculiar velocity meant there absolutely had to be a colossal gravitational force acting on our local region of space.
So why don't we just point a telescope at it and take a look? Well, Section 2, hiding in the shadows, the Zone of Avoidance. The Great Attractor is hiding perfectly out of sight because our own Milky Way is blocking the view. It almost feels like a cosmic joke, doesn't it? We live inside the disk of our spiral galaxy, and when we try to look out along the plane of this disk, all the dense interstellar gas, the dust, the stars, they completely absorb visible light. Astronomers call this massive blind spot the Zone of Avoidance. It obscures about 20% of the extragalactic sky, positioned exactly where the Great Attractor happens to be located. So to bypass this, astronomers quickly realized that standard optical telescopes were completely useless here. They had to pivot. They started relying on X-ray, infrared, and radio wavelengths, specifically looking at the 21-centimeter hydrogen emission line, just to peer through our own galaxy's clutter. And solving this wasn't an overnight thing. It took decades of painstaking detective work. In the 1970s, mapping the cosmic microwave background revealed our high-speed drift. Then in the 1980s, a famous collaboration of astronomers, known as the Seven Samurai, which included brilliant minds like Sandra Faber and Alan Dressler, mapped the distances and velocities of about 400 elliptical galaxies. That definitively proved a massive, unseen attractor existed. Fast forward to 2014, and astronomer R. Brent Tully's team beautifully maps out our larger supercluster. And then, in 2017, Uduta Hoffman discovers another massive force at play, which we will get to in just a moment.
But first, let's look at the structure they found. Section 3, Welcome to Laniakea, our cosmic watershed.
To really grasp what astronomers found here, we have to reorient our perspective a bit. The crucial piece is understanding how modern cosmology defines a supercluster. We used to think of superclusters just as static, dense nodes of galaxies packed together, but modern science defines them dynamically as a cosmic watershed. Think about how water naturally flows down the sides of a valley to form a river, eventually draining into a common basin, right? Gravity does the exact same thing on a cosmic scale. Galaxies naturally flow along gravitational gradients toward a common mass basin.
Let's zoom out to see our place in this watershed. Step 1. We live in the local group, which is a modest collection of about 54 galaxies. Step 2. Our local group is being pulled toward the Virgo cluster, a massive structure of over 1,000 galaxies roughly 50 million light-years away. Now, for a long time, we thought Virgo was the center of everything. But Step 3. Studies of those peculiar velocities showed that the Virgo cluster, our local group, and the surrounding clusters are all collectively drifting together as tiny appendages of an unimaginably huge structure, the Laniakea Supercluster, containing roughly 100,000 galaxies.
Laniakea, which translates beautifully to immense heaven in Hawaiian, spans a jaw-dropping 520 million light-years. And seeing this structure finally resolves our core mystery. The Great Attractor isn't some exotic monster or a supermassive black hole consuming the universe. It's simply the dense gravitational focal point, the bottom of the basin, at the very heart of the Laniakea Supercluster. Every single galaxy within Laniakea is effectively on a gravitational trajectory down into this valley.
Let's run through the staggering empirical data that makes up this basin. The Great Attractor sits somewhere between 150 to 250 million light-years away from Earth. Its estimated mass is roughly 10 to the 16th power solar masses. Just to put that into perspective, that is tens of thousands of times the mass of our entire Milky Way. At its central hub sits the Norma Cluster, which is a massive cluster undergoing severe gravitational collapse. And importantly, the immense mass required to generate all this pull isn't just stars and gas. It's heavily driven by the invisible scaffolding of the cosmos, dark matter.
But just when astronomers thought they had the map figured out, they found another layer to this cosmic Russian doll. Section 4. The Pushing and Pulling, a Cosmic Tug-of-War.
So remember earlier how I said the Great Attractor is our destination? Actually, scratch that. It's more like a waypoint. Current research reveals we are in the middle of a massive cosmic tug-of-war. Far beyond the Great Attractor, about 650 million light-years away, lies the Shapley Supercluster, literally the most massive concentration of galaxies in the local universe. Shapley is pulling the Great Attractor and all of Laniakea toward it. But wait, that's only half the story. On the exact opposite side of us, Yehuda Hoffman's team discovered the Dipole Repeller. This is a vast, mostly empty void. And because voids lack mass, they exert less gravitational pull than the universal average. So effectively, this vast empty space is pushing us away. We're caught right in the middle, being pushed by the void and pulled straight toward Shapley, straight through the Great Attractor. With all of these immense forces at play, where does the science actually go from here? Section 5, our uncharted future, mapping the unseen.
The zone of avoidance is obviously still a massive hurdle for us, but over the coming years, we're going to see a total revolution in how we map this hidden region. The Square Kilometre Array currently being built in Australia and South Africa will be the world's largest radio telescope. It's perfectly designed to map neutral hydrogen in millions of hidden galaxies with unprecedented clarity. Meanwhile, the James Webb Space Telescope and the upcoming Nancy Grace Roman Space Telescope are going to provide incredibly deep infrared observations. Working together, these next-generation instruments aim to pierce right through our galactic dust and create a highly detailed 3D map of the local cosmic web.
Which leaves us with one final, deeply profound question to ponder as we wrap up this explainer. The Great Attractor is pulling us relentlessly, but will we ever actually arrive? There are still massive unanswered questions about dark energy, the force that's actively accelerating the expansion of the universe. Current models actually suggest that this cosmic expansion is accelerating so rapidly that our local group might never reach the center of the Great Attractor. The expansion of the very fabric of space might outpace the gravitational pull on these immense scales, effectively tearing our watershed apart long before we ever reach the basin. It is a wildly humbling reminder of the vast unseen forces shaping things on a grand scale. Thank you so much for joining me on this journey today. Keep looking up and keep seeking to understand the magnificent cosmos we call home.